So this problem is asking find the equation of the line through P equal to 4 and 12 such that triangle bounded by this line and the axis in the first quadrant have minimal area. So there's minimal area, we know it's an optimization, and let's try to draw a picture and go from there basically. So there is a point 4 and 12 in the first quadrant, and we want to draw line through that point. Well, I messed up my point a little bit, so I'm going to put the point a little bit further that way. It's just a picture, right? And so now through that point I want to find the area of a triangle that basically I want to find the line, the slope of the line, so that this triangle that is formed right there is the smallest area. So we have previously done similar problems to this, and a lot of times we chose the angle. So for different angles right here, maybe the size of the triangle changes. This time around, I'm just going to use the slope. So first thing first, let's talk about what the objective function is. So objective here is to minimize the area of this triangle. What is the area of a triangle? It's one side times the other side divided by 2. I'm sorry, the area of the triangle is the side, the length of the base times length of the height divided by 2. In the case of the right triangle, it would be just this side times the other side divided by 2. And so I have to name these variables though. So I'm going to call this A and call that one B, which makes this intercept A and 0, and that one 0 and B. Okay, so objective here is basically to minimize A or area equal to A times B. This is A divided by 2. Now, the next thing is that what is the restriction in resources that I have? What is the constraint? And I look at this shape, and the constraint is I have to go through this point. And so basically, the constraint for the slope is as going through that point. And so let's try to find the slope that goes through that point. And so I have this variable A and 0 and 0 and B. I mean A and 0 and 0 and B over there. So let's connect those through the slope. So how do I go about this? What I'm going to do is to choose to write the slope using this point and this point first. So I'm into constraints now. Constraints. And so one way of dealing with it is this, going through these two, and then the other one is through 0 and B. Oops, sorry. This is supposed to be A and 0, not A. Therefore, A and 0. And the other set are these two, 4 and 12. Now, let's find the slope through this and find the slope through that. M is equal to 0 minus, or let's go 12 minus 0 and 4 minus 8. The other way of writing slope is B minus 12 divided by 0 minus 4, right? Let's avoid that and do it the other way around. So it will be dividing by negative value. So it would be 12 minus b divided by 4, basically. Now let's go over here, and I want to eliminate m. I just there are too many variables, m, a, b, and so I set the two of them equal to each other by eliminating m. Then the next thing that comes about is that, well, I really need to solve one variable in terms of the other, and b is here in the numerator. So what I'm going to do is multiply both sides by 4 and write 12 minus b is equal to 48 over 4 minus a. And then solve for b to get b equal to, so I'm adding b to both sides, subtracting this expression from both sides, and that's my final answer. I'm going to box this one because that's the good constraint part, right? That I simplified the constraint to that. Now, what I'm going to do is to, in the objective function, let's go back to the objective function. I'm going to multiply b by a and divide by 2 to get the area in terms of a. When I'm multiplying, I'm basically multiplying by a half, right? Because b is already here. I'm multiplying by a half. And I multiply it by each term, rather than putting the entire b in a parentheses and then distributing later. So I'll multiply 12 by a half, that would be 6a. Then I'll multiply 48 divided by 4 minus a, and by a half, and I get 24a divided by 4 minus a. Now, my friends, when it's time to take the derivative and do the calculus in here. So far what I did is the area of the triangle in terms of a. Now I'm taking the derivative, and that's a prime of a equal to, with respect to a, it's 6 minus derivative of top times the bottom, so that's 24, 4 minus a, that's low d high minus high d low. Yes, and then you multiply the derivative of the low times the high, which derivative of the low is negative 1. So derivative of the denominator is negative 1. So negative times negative 24 over 4 minus a. Oh, to power 2. Okay. So far not bad. And 6. If I distributed this, let me distribute it quickly right here. Oops. So I have 24 times 4, which is 96 minus 24a plus 24. Hold on. 4 times 4, 6. No, 96 is correct. So now I have on top minus 96 over 4 minus a to power 2. I'm going to keep it that way and not do anything further than that because I'm just solving for, at this point I'm going to solve for the critical number anyway. Critical number is going to be setting that equal to 0, 6 minus 96 over 4 minus a to power 2 equal to 0. And that gives me, basically, take the other side, 4 minus a to power 2. And this gives me 4 minus a to the power 2 is equal to 96 divided by 6, which is going to be 96 6, and that is going to be 16, I think. Okay, and so this means that 4 minus 8 is equal to plus minus 4. One of these answers are going to be positive, one of them is going to be negative, and I know A is supposed to be in the first quadrant, so it has to be positive. So one of them is going to be 0 actually. So A is equal to 0, or A is equal to let's see, if I use the negative sign, I get 8. Two situations that and this. 0 doesn't make sense because then there won't be any triangle form the way that we want. So A equal to 8 is the critical number, basically. Now, so I found the critical number. Now what do I need to do? The problem is asking me to find the over here. So it's asking to find the equation of the line, basically. So I have to find the m still. So one way is to plug in a into one of the equations of the m that you have, which you really do right here. I can plug it into there, and it would be 12 over 4 minus 8, which is negative 4, and you get negative 3 as m. So the critical number gives me m equal to 12 over 4 minus 8, which is negative 3. And I can write the equation of the line after that. But let's make sure that this gives me the minimal value of a. So how do I make sure? Again, I have to think about the domain and so on and so forth. So let's see, domain in here, let's go back. So A really cannot be anything less than 4. Otherwise, that triangle doesn't form, right? If it's over here, it's going to not intersect the y-axis in the first quadrant. It's going to intersect it in the fourth quadrant. Between 0 and 4. And therefore, basically, the A starts at 4, and we can put to infinity, but also, so domain is open for an infinity. And what is important here is that in for an infinity, A equal to 8 is the only critical number. So if I draw the basically the f prime, the sign only changes at 8 when we're in between 4 and infinity. Not before that, but over here. And what I know is that the area increases on both sides. As a goes to positive infinity, area goes toward basically positive infinity, and as a goes to 4, area goes to positive infinity. Let's try to take a quick look again. So as we basically approach 4 over here, one side gets to go closer to infinity, and as again a goes to this way to positive infinity, one side gets closer and closer to infinity. Therefore, I know that basically starting from close to 4, we're going down and going up. Therefore, min is at a equal to 8. So I think we're pretty much done. The last piece is to use that m to write down the equation of the line. And equation of the line, I can use m equal to -3 and a point, 0.8 and 0. And so what I get is y is equal to -3 times x minus 8. And that's the equation of the line that gets you the minimal area.